The Aurora Australis, the Southern Lights. We are transported to the vast, icy southern regions of our planet, where the night sky transforms into a ballet of colors and lights. The Aurora Australis is one of Earth's most magnificent and mysterious natural spectacles, the southern polar equivalent of the famous Northern Lights. To understand the cause of the Aurora Australis, let's imagine that our planet has an invisible shield and that the sun, in the distance, is like a particle cannon. Imagine the Earth as a giant magnet. It has an invisible magnetic field, like a large protective shield, extending from the North Pole to the South Pole. At the same time, our sun constantly blows a wind, called the solar wind, composed of tiny, energetically charged particles, like tiny bullets. When this solar wind, the sun's bullets, travels through space and encounters Earth's magnetic field, our planet's shield, most of these particles are deflected. It's as if they hit the shield and were pushed aside. However, some of these particles manage to slip through and are drawn toward Earth's poles, both the North and South poles, where the magnetic field is weaker and they can penetrate the atmosphere. Imagine this as if the particles were channeled toward the doors at the poles of our protective shield. When these charged solar particles enter our atmosphere, made up of gases like oxygen and nitrogen, the same ones we breathe, they collide with the molecules of these gases. It's like a mini cosmic collision. And that's where the magic happens. As they collide, these particles transfer energy to the gas molecules, making them glow for a moment. Think of it like turning on a light bulb. The electricity causes the gas inside to glow and produce light. In the same way, these collisions in the sky make the air glow. The different colors we see, green, pink, purple, blue, depend on the impacting gas, oxygen or nitrogen, and the altitude at which the collision occurs. For example, the bright green color, which is more common, usually comes from oxygen at lower altitudes. In short, it's a grand cosmic dance between energetic particles from the sun, Earth's magnetic shield, and atmospheric gases. The result is a ballet of light that illuminates the night sky in the polar regions, including the dazzling Aurora Australis. Is it easier to visualize how this incredible phenomenon occurs? Where and when to see the Aurora Australis? Finding the setting for the Southern Lights. To witness the Aurora Australis, you need to venture to the southernmost regions of our planet, to places close to the South Pole. Consider the most remote and coldest places on Earth as the best places for this light show. Best places to see it. Antarctica is undoubtedly the best place, but it's difficult to access for most people. Therefore, the most common destinations to see the Aurora Australis include Tasmania, Australia. This island south of Australia offers excellent opportunities, especially on clear winter nights. New Zealand South Island. Places like Queenstown, Lake Tekapo, and Stewart Island are famous for their dark, clear views. Patagonia, Chile and Argentina. Although less frequent and often dimmer, the aurora can be seen from points as far south as Patagonia. Subantarctic islands. Islands such as the Falkland Islands and South Georgia are remote and offer spectacular views, but are difficult to reach, usually by expedition crews. When the auroras shine most intensely. The best time to see the Aurora Australis is during the winter months in the southern hemisphere, from March to September. Just as winter nights in your city are longer, nights at the poles are even longer, providing more hours of darkness for the auroras to be visible. In addition, the intensity of the Aurora Australis depends on solar activity. The more intense the storm of particles from the sun, the brighter and more frequent the light show will be. There are auroral activity forecasts that observers can consult. In short, to see the Aurora Australis, you need location, be as close to the South Pole as possible. Darkness, long nights without light pollution, away from cities. Clear skies, no clouds to interfere with the view. Solar activity, the more intense the solar activity, the better the show. The cosmic dance of colors, the Aurora Spectacular. Imagine the sun itself painting the sky with brushstrokes of light, a cosmic work of art revealed when its particles touch our atmosphere. This is the aurora, a breathtaking ballet of colors and shapes. The colors we see in this light show depend on a very special encounter, what type of gas is in the atmosphere and at what altitude it is touched by the particles coming from the sun. The celestial palette. The most common and vibrant color is emerald green. Think of the deep green of the most beautiful grass, but glowing 100 or 200 kilometers above us. This is atmospheric oxygen responding to the sun's contact, dyeing the sky with its luminous signature. But the aurora can also surprise with shades of pink, purple, and even intense red. These more unusual colors appear when solar particles collide with nitrogen, especially at lower altitudes, less than 100 kilometers. It's as if the sky turns a deep blush, indicating more intense solar activity and an even more vivid display. At high altitudes, oxygen and nitrogen can create softer blues and violets, almost a delicate veil across the sky. The shapes that enchant. The most fascinating thing is that the aurora isn't static. It's an invisible dance in the sky, changing shape in a matter of seconds. It often begins as long arcs or beams of light stretching across the horizon, a soft glow barely distinguishable from the clouds. But when solar activity intensifies, these arcs come to life. They transform into majestic curtains or beams of light that seem to hang from the sky. Imagine gigantic curtains of colorful silk gently billowing in a cosmic wind, or vertical spotlights pointing into infinity. And at the height of this spectacle, if you're lucky enough to be right underneath, these curtains can converge into a brilliant corona right above your head, an unforgettable 360-degree light show. It's the Earth and the Sun in artistic collaboration, creating one of the largest and most impressive light shows in the universe. In addition to being a visual marvel, the Aurora Australis is a phenomenon of great scientific interest and contributes, albeit indirectly, to human life and activities in the coldest regions of the planet. There are those who not only admire this cosmic spectacle, but also discover its secrets. Imagine scientists as aurora hunters, but with a technological arsenal that allows us to understand the interaction between the sun and Earth. To observe the aurora in all its splendor and decipher its message, scientists use cutting-edge tools. At research bases located at the farthest reaches of our planet, such as Antarctica, polar observatories are equipped with special instruments. Magnetometers measure the Earth's magnetic field, while spectrometers analyze the auroral light to tell us which gases are shining and at what altitude. But surveillance goes far beyond Earth. Satellites orbiting our planet and space probes traveling toward the sun constantly monitor the solar wind. They are our space weather services, alerting us when a solar storm is approaching. With this data, we can predict in advance the brightness of the auroras and where they will shine most intensely. And to ensure that no detail is missed, special high-sensitivity cameras, using long exposure techniques, capture the beauty and movements of these lights, transforming them into valuable data for study. These studies help us understand not only the magnetic fields of the sun and Earth, but also the fascinating interaction of space energy with our atmosphere. The cosmic touch, influence and inspiration. For humans and most animals, the aurora itself has no direct impact on our daily lives, like rain or heat. It does not warm the environment or alter the weather in any perceptible way. However, the intense solar activity that generates the aurora can occasionally have indirect consequences. Communications, strong solar storms can cause a kind of cosmic interference. They can disrupt radio, GPS, and satellite systems, affecting communications in the polar regions and even flights over them. Power grids. In very rare cases, extremely intense auroras can cause power surges in high-voltage power grids, especially in countries near the poles. However, these are very rare events, and systems are built with safeguards to cope with them. Undoubtedly, the greatest impact of the aurora on our lives is the beauty and inspiration it brings. For those fortunate enough to witness the spectacle, whether living in the polar regions or as admiring visitors, it is a transformative experience. It is a vivid reminder of the complexity and grandeur of our planet, connecting us to the vastness of the universe. Thank you so much for joining me on this exploration of one of the most incredible places on our planet. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating trips.